The atoms in your right hand were forged in a different star than the atoms in your left hand. Sit with that for a moment. Two separate suns, each one born, each one dying in a spectacular explosion, each one seeding the void with the raw material that would, billions of years later, become the fingers you are using to hold your phone or your cup of tea right now. And here is the strange part. According to the plainest reading of the laws of physics, none of it should have happened at all. You should not be here. Not you specifically, though that too. I mean matter. I mean anything solid. I mean the fact that there is something rather than nothing arranged into stars and planets and people who can wonder about it. The universe, if it had followed its own most basic rule book to the letter, should have canceled itself out in the first fraction of a second and left behind a smooth, cold, empty glow. No galaxies, no carbon, no you. But you are here, which means something happened. Something the rules, as we understand them, forbid. A tiny imbalance, a rounding error in the accounting of creation. And that error is the reason you exist. I know how that sounds. Dramatic, almost mystical. So let me be honest with you before we go one step further. I am not a scientist. I have not run these experiments. I am just a fellow traveler who got obsessed with a question and started pulling on the thread. Everything I am about to walk you through, you can follow from your armchair. No equations, no credentials required, just careful thinking, one step at a time. And that is the promise of the whole thing. Not that I will hand you a fact to swallow, but that we will build the reasoning together, brick by brick, until you can see the impossible thing standing there for yourself. When we reach the astonishing claims, and we will, you will not have to take my word. You will already have laid the floor beneath them. That is the only kind of knowing worth having. Most people walk around believing their existence is ordinary, unremarkable, a given, that the world is simply here and always would have been, and there is nothing to explain. That is the belief. And it is almost the exact opposite of the truth. The truth is that your existence is the single most improbable thing you will ever encounter. And the fact that it feels ordinary is only because you have never been shown the ledger. So let's open the ledger, let's sit with the impossible thing, and then let's figure out exactly how impossible it really is. Before we can talk about the law the universe broke, we have to be honest about something uncomfortable. How do we know anything at all about the beginning of everything? Nobody was there. There is no eyewitness. There is no photograph from the first second. So on what grounds does anyone get to make claims about a moment that happened nearly 14 billion years before the first human opened its eyes? This is the part most people skip. They want the answer. They want the punchline about why you exist. But the answer is worthless if you do not first understand how we could possibly know it. So let's build that foundation carefully together. Here is the first tool, and it is the most important one. Distance and time are the same currency. When you look at the moon, you are not seeing the moon as it is now. You are seeing it as it was a little over 1 second ago, because that is how long its light took to reach your eye. Light is fast, but it is not infinitely fast. It has a speed limit, and that speed limit is the single most useful fact in all of astronomy, because it turns the whole sky into a time machine. Look at the Sunday. You are seeing it as it was 8 minutes ago. If it vanished this instant, you would enjoy 8 more minutes of sunshine, entirely unaware. Look at the nearest star beyond the sun, and you are peering 4 years into the past. The distance light travels in a single year we call a light year. It is a measure of distance, but it is secretly a measure of time. And this is not a trick or a metaphor. It is just how looking works when the thing you are looking at is far away. Let me make that concrete. Because it is easy to nod along and not quite feel it. Light crosses the gap from the Earth to the moon in about 1.25 seconds. It takes 8 minutes and a bit to cross from the Sunday. To reach the next nearest star, it needs more than 4 years. To cross our own galaxy, edge to edge, light needs about 100,000 years. So when you look at a star on the far side of the Milky Way, The light landing in your eye tonight left before there was writing, before there were cities, before there was farming. It is that old, and it is arriving right on schedule. And here is a way to feel the reach of it that I keep coming back to. The light from the sun that warms your face this morning left the sun's surface 8 minutes ago. But the energy carrying it began its journey out of the sun's core tens of thousands of years earlier, clawing its way to the surface. So in a strange double sense, the sunlight on your skin is ancient. Now stretch that intuition outward. There are galaxies whose light left them before the Earth had even formed. The Earth is around 4.5 billion years old. There is light arriving tonight that has been traveling for 2 or 3 times that long. It set out toward a place that was not yet a place, aimed at nobody, and it happens to be landing now in an eye that did not exist when it began. That is the sky, a vast archive of arriving pasts, sorted by distance. Now push this further, because this is where it gets thrilling. When we point our most powerful instruments at the faintest, most distant smudges of light in the sky, we are not looking across space so much as looking backward through time. Some of that light has been traveling for more than 13 billion years. It left its source when the universe was an infant. So when we study those ancient galaxies, we are literally watching the early universe happen. Not a reconstruction, not a guess. The actual light actually arriving right now, having crossed almost the entire history of the cosmos to land on a mirror we built. This is why the James Webb Space Telescope matters so much. It was designed to catch that ancient, stretched out light, and stretched is the right word. As the universe expands, the light traveling through it gets pulled to longer, redder wavelengths, a phenomenon we call redshift. The more redshifted the light, the further it has traveled, the older it is. Redshift is our yardstick for the depths of time. The further back we look, the redder everything becomes. And here is a detail worth savoring. That telescope was built to see in the infrared, in the deep red light beyond what your eye can catch, precisely because the most ancient galaxies have had their light stretched so far by the expansion of space that it is no longer visible at all to a human eye. The light left those galaxies as ordinary starlight. It arrives 13 billion years later as a faint infrared glow. We built an instrument tuned to exactly that stretched out whisper. And to catch a whisper that faint, we had to fly the telescope 1,000,000 miles from Earth and cool it to within a whisker of the coldest temperature there is, so that its own warmth would not drown out the ancient signal. That is how careful you have to be to read the past. And when it looked, it found galaxies already formed and shining far earlier than the simplest story said they should be, which is its own small crack in the rule book and its own invitation to look harder. But there is a wall. There is a moment beyond which we cannot see, no matter how good our instruments get. For the first few 100,000 years, the universe was so hot and dense that it was opaque. Light could not travel freely. It bounced around, trapped, like sunlight inside fog. Then the universe cooled just enough, and in one cosmic instant, it became transparent. The trapped light was suddenly free to fly, and it is still flying. It is still arriving. We call it the cosmic microwave background, and it is the oldest light there is. It is a photograph of the universe as a toddler, taken from the inside. That background glow is the edge of what can be known by looking. It is a horizon. We cannot see past it with light, because before it, there was no free light to see. So already you understand something profound about knowledge itself. There are limits. There are walls. And a good thinker does not pretend the wall is not there. A good thinker walks right up to it and says, this far, and here is exactly why, no further. There is one more trick worth having in your pocket before we go on, because it will matter later. Light does not always travel in a straight line. When it passes a very massive object, a great cluster of galaxies, the mass bends the very fabric of space-time around it, and the light bends with it. We call this gravitational lensing. And it turns a heavy cluster into a natural magnifying glass, smearing and brightening the faint galaxies behind it. We use those cosmic lenses to see further than our instruments alone could ever reach. I mention it not to overload you, but to show you the flavor of the whole enterprise. Every limit we hit, we look for a clever way around it, and often the universe itself hands us the tool. So how do we reason about what happened before that wall in the very first second when the whole story we care about was written? We do it with a second tool. We take the laws of physics we can test in a laboratory today, and we ask a simple question. If these rules held back then, what would they predict? Then we check the prediction against the fossil evidence the universe left lying around. The proportions of the lightest elements, the pattern of tiny ripples in that background glow, the way galaxies are strung across the sky. Think about how bold that move actually is. We take a rule we can measure on a bench in an afternoon, a rule about how particles behave, and we dare to apply it to a moment nearly 14 billion years gone and unimaginably hotter than anything a bench has ever held. Why should that be allowed? Because those rules leave fingerprints. If a rule held in the first second, it would have shaped the elements that formed, the ripples that froze into the ancient light, the pattern galaxies fell into. So we do not have to travel back. We only have to read the fingerprints and check them against the prediction. If they match, the rule held. If they clash, the rule failed. The past leaves evidence in the present, and evidence can be read from a chair. And here is the honest bit. A prediction is only worth something if it could have been wrong. That is the whole game. An idea that explains everything and could never be contradicted by any observation explains nothing. It has to be falsifiable. It has to stick its neck out. It has to say, if you look over there, you will find this. And if you find something else instead, I am finished. The theories we trust are the ones that made risky bets and won over and over. Let me give you the flavor of a risky bet that won, because it makes the idea solid. The rules of the early universe predict a very particular recipe for the lightest elements. So much hydrogen, this exact fraction of helium, a precise whisper of a couple of others, that is a bet. It says, go and measure the oldest, most untouched gas you can find, and you will get these proportions and no others. And we went and looked, we found ancient clouds of gas far out in space, gas that had never been cooked inside a star, and we measured what they were made of. And the proportions matched. They could easily have come out wrong and buried the whole idea. They did not. That is what earned trust. Not authority, not a confident voice, a prediction that risked everything and survived the test. There is a discipline hiding in all of this, and it has a name: Occam's razor. When two explanations both fit the evidence, prefer the simpler one until the evidence forces your hand. We do not reach for the exotic answer while a plain one still works. We reach for it only when the plain one breaks against an observation. Hold that principle alongside the other two. Looking far is looking back. Any claim worth believing is a claim that could have failed, and when in doubt, take the simpler road. With those three things in your pocket, an ordinary person in an ordinary chair can reason their way to the edge of the impossible. Let's go. Everything you are made of has a hidden twin, and the two of them are supposed to destroy each other on contact. That is the first impossible thing, and it is not poetry. It is one of the most solidly established facts in all of physics. Let me build this up slowly, because it sounds like science fiction, and it is not. For every kind of particle in your body, there exists a mirror image particle with the opposite electric charge. We call this mirror stuff antimatter. It is not exotic or theoretical. We make tiny amounts of it in laboratories. It behaves exactly like ordinary matter, with one dramatic exception. When a particle of matter meets its antimatter twin, they do not bounce, they do not merge, they do not settle down together, they annihilate. Both of them vanish completely, converted entirely into a flash of pure energy. Nothing left, just light. Let me make the scale of that vanishing vivid, because it is easy to say annihilate and hard to feel it. A single gram of matter meeting a single gram of antimatter would release energy on the order of the largest bombs ever built. From two little pinches of stuff you could hold on a fingertip, that is how completely matter and antimatter erase each other. There is no residue, no ash, no smoke. The entire substance of both is converted, without waste, into radiation. every scrap of it. This is the most efficient destruction the universe permits. Nothing else even comes close. Burning, splitting, crushing, all of these liberate only a sliver of what a thing contains. Annihilation liberates all of it, 100%. The books are emptied to the last coin. Now, here is the thing that should keep you up at night. When we create particles in the laboratory, when we smash energy into matter under controlled conditions, we get matter and antimatter in exactly equal amounts. Always. Every single time. Energy turns into a particle. And it turns into its anti-twin together in perfect balance. This is not a preference the universe shows. It appears to be a rule. Make matter from energy, and you must make an equal amount of antimatter alongside it. The books have to balance. Picture it like a coin that always lands on its edge and splits. Push in a lump of pure energy, and out come exactly two things, a particle and its anti-twin, never one without the other. We have watched this happen countless times in every kind of collision we can arrange. It is as reliable as anything we know. Matter is never conjured alone. It always arrives with its own destroyer attached, and the reverse holds too. Bring the twins back together, and they return to pure energy, the exact amount you started with. Energy into a balanced pair back into energy. A perfectly closed, perfectly symmetric accounting. So follow the reasoning. Rewind to the very beginning, to that fraction of a second, when the universe was nothing but a searing sea of pure energy, hotter and denser than anything that exists today. That energy cooled, and as it cooled, it did what energy does. It turned into particles, matter and antimatter, in equal measure, because that is the only way we have ever seen it happen. Do you see the problem coming? If the universe made exactly as much matter as antimatter, then as everything cooled further, every particle would have found its twin, and every pair would have annihilated matter and antimatter, canceling each other out, particle by particle, twin by twin, until nothing solid remained. Just a universe flooded with light and no substance at all. No stars, no planets. No atoms in your right hand or your left? This is not a wild guess. This is the plain default prediction of the physics we can test on a bench today. A perfectly balanced beginning leads to a perfectly empty ending. Symmetry in, nothing out. By the strictest reading of the rules, the honest expectation is a dead, luminous void. And notice, this is the simple explanation. By Occam's razor, this is the one we should have expected. The symmetric beginning is the tidy story. It is the story that needs no special pleading. And it predicts a universe with nobody in it. And yet, here you are. Here the stars are. Here is a universe stuffed with matter and almost no antimatter to be found anywhere. We have looked. If there were great regions of antimatter out there, we would see the telltale flashes where they meet ordinary matter at their borders. Where a cloud of matter drifted against a cloud of antimatter, the boundary would blaze with that flood of annihilation light, a signal we know exactly how to recognize. We scan the sky for it. Between galaxies, along the edges of great clusters, everywhere two vast clouds might rub against each other, we look for that particular glow. We do not find it. The cosmos is overwhelmingly one-sided. It is made of matter, and its anti-twin has all but vanished from the scene. So one of two things must be true. Either the perfect balance was never quite perfect, or the rules we tested on the bench are incomplete, and something in the early universe tipped the scales. Notice how that works. This is the shape of good reasoning. We have a rule. The rule predicts nothing should exist. Something exists. Therefore, the rule, as stated, is wrong somewhere. The evidence is you. Your existence is the observation that falsifies the simplest version of the story. You are a walking counterexample to the tidiest law we know. Now, here is where it becomes almost unbearably beautiful. We can actually estimate how big the imbalance had to be, because that ancient light, the cosmic microwave background, carries a record of the annihilation. When the matter and antimatter canceled out in the early universe, they left behind that flood of light. So we can count for every particle of matter that survives in the universe today, we can work out how many photons of that leftover light there are. The number is staggering. For every single particle of matter that made it through, there are roughly 1 billion photons of leftover light. Think about what that means. For every billion pairs of matter and antimatter that annihilated, one lonely particle of matter was left over with no twin to cancel it. 1 billion and 1 particles of matter for every billion particles of antimatter, that tiniest of surpluses. 1 part in 1 billion. That rounding error is everything. That is the entire visible universe. Every star, every galaxy, every atom in your body is made from the leftovers, from the survivors of a near total annihilation. Let me hold that ratio in front of you one more way, because it deserves it. Imagine 1 billion pairs of dancers, each dancer partnered with a twin who will destroy them the instant they touch. The music starts, pair after pair meets and vanishes in a flash 1 billion times over. And when the floor is finally empty of pairs, there stands one lone dancer, unpartnered, the single survivor of 1 billion collisions. Now imagine that on the scale of the entire early universe, uncountable numbers of those survivors, 1 in every billion, drifting on into a cosmos suddenly emptied of its destroyers. Those survivors are the stars. Those survivors are the planets. Those survivors are the atoms in your 2 hands. And here is a thought to make it heavier still. If that surplus had been even smaller, say 1 part in 10 billion instead of 1 part in 1 billion, there would be far less matter in the universe, too thinly spread to build much of anything. Nudge it the other way, and the balance of the whole cosmos changes. The exact size of the leftover mattered. It was not just that there was a surplus, it was that the surplus was the right size to fill a universe with stars. You are built from a rounding error in the accounting of creation, and nobody fully knows why the error was there or why it was that particular size. Now watch this same shape appear again in completely different territory, because the problem of existing is not only about being made, it is about not falling apart. And by the same plain reasoning, the universe should never have held itself together long enough to build a single galaxy. Let me start somewhere you already understand in your gut. Throw a ball into the air, it comes back down. Throw it harder, it goes higher, but still it returns. Gravity always wins. Unless you throw it so hard that it never comes back at all. There is a speed, a specific speed, at which an object breaks free of a planet's gravity forever and never returns. We call it escape velocity. For the Earth, it is about 7 miles every second. Below that speed, you fall back. At that speed or above, you are gone. It is a threshold, a clean line between falling and flying. And notice how ordinary that idea is, even though it governs the entire cosmos. It is the same physics that decides whether a rocket reaches orbit or tumbles back into the sea. The same orbital mechanics that hold the moon in its circle and keep the planets threading their paths around the Sunday. A little more speed and you leave. A little less and you fall. There is a knife edge built into the very idea of gravity, and you have felt a version of it every time you have thrown anything upward and watched it come down. Let me make that knife edge personal for a second. If you could somehow throw a stone at 7 miles a second straight up, it would never come back to you, ever. It would leave the Earth entirely and sail off into the solar system. A hair slower, and it climbs, slows, stops, and falls back into your hand. That difference between a stone that returns and a stone that is lost to the cosmos is a razor-thin difference in speed. Gravity is full of these thresholds. Cross them and everything changes. And the whole universe, it turns out, sits on the biggest threshold of all. Now hold that idea and scale it up to the whole cosmos, because the whole universe is doing something like a throw. It began expanding from that hot, dense beginning, and everything has been flying apart ever since. Every galaxy rushing away from every other, and gravity, the collective pull of all the matter in existence, is trying to slow that expansion down, trying to pull everything back, trying to reverse the throw. So you have two competing tendencies: the outward rush of expansion and the inward pull of gravity. And here is the knife edge. The fate of the entire universe depends on the exact balance between those two forces. Right at the beginning, think about how delicate this is. If gravity had been just slightly too strong at the start, if the expansion had been just a hair too slow, then gravity would have won early. The whole universe would have slowed, stopped, and collapsed back in on itself. A great crush, everything falling back together in a fraction of the time it takes a galaxy to form. No time to build stars, no time to build you. Collapse before creation. But swing the other way. If the expansion had been just slightly too fast, if the outward rush had beaten gravity by even a small margin, then matter would have flown apart too quickly for gravity to gather it. The universe would have thinned out into a cold, empty spray. Atoms drifting apart faster than they could ever clump into anything. No galaxies, no stars, just an ever-thinning fog spreading into the dark, dispersal before assembly. So on one side, collapse. On the other side, dispersal, and in between, a razor-thin path where the expansion and the gravity are so finely matched that the universe neither crushes itself nor flies apart, a path where things hang together just long enough and clump together just densely enough to make stars and galaxies, and eventually a planet where someone can sit and marvel at how narrow that path was. Now, here's the question that ought to stop you cold. How finely balanced did those two forces have to be at the very beginning to land on that path? The answer defies the imagination. Reason it through with me. The balance had to be right not to 1 part in 10, not to 1 part in 1,000, not to 1 part in 1,000,000. Trace the arithmetic back to the earliest moment we can sensibly talk about, and the expansion in gravity had to match to a precision. So fine, it strains the language. Something like 1 part in a number with dozens of zeros after it tipped the scale by that unimaginably tiny amount in either direction, and there is no universe fit to live in. Too much gravity? Crush. Too little? Drift. And the window in between is narrower than any margin you have ever encountered in your life. Let me put the order of magnitude in human terms, because that is the only way to feel it. Imagine you had to throw a dart across the entire width of the observable universe and hit a target the size of a single atom. That is roughly the kind of precision we are talking about. And the universe hit it at the very first instant with no second attempt. Try another version of the same feeling. Picture a pencil perfectly sharpened and imagine balancing it on its point on a tabletop. You know, it falls at once, one way or the other. Now imagine balancing it so precisely that it stands there not for a second, not for an hour, but for 14 billion years, never tipping toward collapse and never tipping toward drift. That is the kind of balance we are talking about. A pencil on its point, holding steady for the entire age of the cosmos. That is what the expansion and gravity had to do at the very first instant, and did. And here is one more way to feel the tightness of it, because I want it to really land. Think about how quickly this balance would have to go wrong if it were even a touch off. We are not talking about a universe that drifts off course over billions of years. A tiny imbalance at the very start would have runaway consequences almost immediately, either slamming everything back together or blowing it apart long before the first star could form. The correction window was not just narrow, it was narrow at the earliest instant when everything was moving fastest and any error would grow quickest. And the universe threaded it anyway. I know how that sounds. It sounds like it must be rigged. It sounds designed. And I want to be careful here, because this is exactly the moment where careful thinking matters most. The temptation is to leap straight to a grand conclusion, but a good thinker slows down. There may be a mechanism we have not fully grasped that makes this balance natural rather than miraculous. There are ideas about how the early universe might have smoothed and flattened itself automatically, driving the balance toward that knife edge without any fine-tuning at all. Those ideas make predictions. Some of those predictions have been tested against the ripples in that ancient light, and they have held up remarkably well. Here is roughly how that kind of idea works. So it is not just a phrase I wave at you. Imagine the early universe stretched. in a fantastically brief instant by an enormous factor. Take any surface, however curved, and blow it up huge, and the little patch you are standing on looks flat. Stand on a beach ball and you feel the curve. Stand on a planet and it feels flat under your feet, though it is the very same kind of surface, just blown up enormously. That same trick, applied to the whole cosmos, could flatten the balance between gravity and expansion, driving it automatically toward that razor's edge, no fine adjustment required. And crucially, that stretching would leave a signature, a particular pattern in the ripples of the ancient light. We went and measured those ripples. The pattern was broadly there, not a proof, but a risky bet that largely paid off. That is the difference between a mechanism and a miracle. A mechanism sticks its neck out and can be checked. A miracle just asks you to stop asking. So the honest position is not the universe was designed, and it is not the universe is a lucky accident. The honest position is that the balance is real, it is astonishingly precise, and the question of why it sits exactly where it does is still open. That is not a weakness. That is the frontier, and you get to stand right at it. The point that matters for you sitting in your chair is this. By the plain accounting of gravity and motion, the universe had no business holding together. It should have crushed itself or scattered itself. Instead, it threaded a needle finer than anything you can picture. And on the far side of that needle, matter had the time and the density it needed to gather into stars. Which brings us to the third impossible thing. Because even a universe that holds together, even a universe with a little leftover matter, still has to build the specific atoms you are made of. And that turns out to be a story of a bridge that should not exist. You are mostly made of an element that, by the rules of how stars build things, should be almost impossible to make. Carbon, the backbone of every living thing you have ever seen, and the way stars manufacture it involves a coincidence so precise that when it was first understood, it stopped people in their tracks. Let me lay the groundwork. In the beginning, the universe made only the very lightest elements. Hydrogen, the simplest thing there is, a single particle. A good deal of helium, the next simplest, and a whisper of a couple of others. That is all. The early universe was a factory that produced only the plainest raw materials. No carbon, no oxygen, no iron, none of the rich, heavy elements that make chemistry interesting and life possible. Just the light stuff. So where did the carbon in your body come from? Where did the oxygen you are breathing right now come from? They were built later inside stars. A star is a furnace. In its core, it takes the light elements and, under crushing pressure and heat, fuses them into heavier ones. Hydrogen fuses into helium. That is what makes a star shine. And when a star runs low on hydrogen, it starts fusing helium into heavier things still. This is where the heavy elements are born, in the bellies of stars. And here's a thought worth pausing on. Every heavy atom in you was cooked in a stellar furnace and then flung out into space when that star died, so that the raw material could gather again into a new cloud, a new star, a new planet, a new you. The iron in your blood, the calcium in your bones, the carbon in every cell, all of it passed through the core of a star that lived and died before the sun was ever born. When I said the atoms in your two hands came from different stars, that is not a flourish. It is the plain history of the stuff you are made of. You are quite literally reassembled stardust. And this is why the timing of the first two impossibilities matters so much. You needed a universe that made matter at all. Then you needed it to hold together long enough for whole generations of stars to be born, to live, to die, and to seed the next generation with their ashes. Only then could a planet gather from those ashes. Only then could there be a you. Each impossibility had to be cleared before the next one could even begin. But here is the obstacle, and it is a serious one. To build carbon, a star needs to fuse 3 helium cores together. Carbon is, in effect, 3 helium stuck as one. And the natural way to do that would be one step at a time. First, fuse 2 heliums together, then add a third. Simple enough. except for one catastrophic problem. When you fuse two helium cores, the thing you make is wildly unstable. It falls apart almost the instant it forms. It exists for a flicker, a span of time so short it barely deserves the name, and then it is gone. So think about what the star is up against. To make carbon, it needs a third helium to crash into that two helium object during the impossibly brief flicker before it disintegrates. The odds of that timing are appalling. It is like trying to build a bridge by throwing 3 stones into the air and needing all 3 to collide and stick at the exact same instant, when the first 2 only hold together for the blink of an eye. By any reasonable accounting, carbon should be vanishingly rare. The universe should be starved of it. And a carbon-starved universe is a universe with no life in it at all, no backbone for chemistry, no long, complex molecules, no living thing of any kind that we could imagine. And yet, look at the universe. It is not starved of carbon. Carbon is abundant. It is everywhere. It is in the stars, in the dust between the stars, in the planets, in you. So once again, the plain reasoning predicts scarcity, and the observation screams abundance. Something is making carbon far more efficiently than the simple story allows. Something is helping the third helium arrive in time. Here is where the reasoning becomes genuinely thrilling, because it is a case of prediction leading discovery. Someone reasoned exactly the way we just did. They said, we exist, we are made of carbon, therefore carbon must be easy to make. Therefore, there must be something we are missing that makes it easy. And they predicted, on the strength of nothing but the fact of their own existence, that carbon must have a special property, a hidden resonance, a particular energy level that acts like a matched frequency, so that when the third helium approaches, everything lines up and the fusion happens far more readily than blind chance would ever allow. Like pushing a child on a swing at exactly the right rhythm, so a tiny push produces a huge result. Let me linger on that swing, because it is the heart of it. You know from a playground that if you push at just any moment, nothing much happens. You waste your effort. But push in time with the swing's own rhythm, matched exactly to its natural beat, and each small push adds up until the child is soaring. A resonance is that matched beat. The claim was that carbon has a natural energy level sitting at precisely the right spot, so that the incoming helium arrives in rhythm, and the reaction that should almost never happen instead happens readily. Without that matched level, the third helium would arrive at a time, the fleeting 2 helium object would fall apart before it could bond, and carbon would stay rare. The whole abundance of the element hangs on that one tuned note, and the note had to be tuned to a very particular pitch, a little higher or a little lower, and the resonance would not line up, and the bridge would not hold. This special energy level had to exist, they reasoned, or we would not be here to reason about it. It was a prediction made purely from the fact of existence. And then they went and looked. They went into the laboratory and measured the energy levels of carbon directly. And it was there, exactly where the reasoning said it had to be. The universe had built a hidden bridge across the impossible gap, and the only clue that the bridge existed was that we had already walked across it. Sit with the strangeness of that. The proof that carbon could be made easily was that carbon-based creatures were standing around asking the question. Your existence was the evidence. You were the falsifiable prediction, and the universe passed the test. And notice, this was not a comfortable idea that explained everything and risked nothing. It was a sharp, specific claim. There must be an energy level at roughly this value, or the reasoning collapses. Go and measure it. If it is not there, the whole idea is dead. That is a real bet, and the measurement found the level right where it had to be. This is scientific reasoning at its most daring and its most honest. A claim that could have died in the laboratory that same afternoon and instead survived. And notice, this is the same shape a third time. A rule that predicts you should not exist. Matter should have annihilated itself. The universe should have crushed or scattered. Carbon should have been too rare to build a body. 3 separate impossibilities in 3 separate domains, and every one of them resolved by the barest, most precise margin. a rounding error, a knife edge, a hidden bridge, and every one of them, in the end, pointing at the same quiet astonishment. So let's bring these three threads together, because on their own, each is a curiosity, but laid side by side, they start to tell a single story. And it is a story about you. Look at what we have. Three completely different problems from three completely different corners of physics. The problem of being made at all, where matter and antimatter should have canceled to nothing. The problem of holding together, where gravity and expansion should have crushed or scattered everything. The problem of being built from the right stuff, where carbon should have been too hard to forge. These are not variations on one theme. They come from different equations, different eras, different physics entirely. A person could spend a lifetime on any one of them and never touch the others. The first is about the very first fraction of a second. The second is about the shape of the whole cosmos across billions of years. The third is about what goes on in the crushing heart of a single star. Utterly different scales, utterly different questions, and yet every single one has the same shape. In each case, the plain, default, honest reading of the rules predicts a dead universe. No matter, or no structure, or no chemistry. In each case, the universe slipped through by the narrowest possible margin. One extra particle per billion. A balance precise to dozens of decimal places. An energy level tuned like a struck bell. And in each case, the proof that it happened is not some abstract measurement. The proof is that you are here to ask about it. This is where the mediocrity assumption becomes interesting to turn over in your hands. The Copernican principle, the idea that we are not special, that our position in the cosmos is nothing remarkable, has been one of the most reliable guides in the history of thinking. We are not at the center of the solar system. The sun is not at the center of the galaxy. Our galaxy is not at the center of anything. Over and over, the assumption that we are ordinary has proven correct, and the assumption that we are special has proven to be vanity. So here is the tension, and it is a delicious one. The universe we live in looks, in these three deep respects, extraordinarily special, finely balanced, improbably arranged, exactly hospitable. How do we square the humility of assuming we are ordinary with a cosmos that appears so precisely fitted to allow us? There is a way, and it is subtle, and it is worth sitting with. It may be that the balance only looks miraculous because we are stuck inside a universe that permits observers. Any universe that produced beings capable of noticing anything would by necessity be one of the rare balanced ones. The crushed universes and the scattered universes have nobody in them to be surprised. So the very act of being here to marvel guarantees that what you observe will be marvelous. You can only ever find yourself in a universe capable of holding you. Let me put that argument in a plainer shape because it is slippery and important. Imagine a vast lottery with almost every ticket a loser, a dead and empty cosmos, and only the rarest ticket a winner. A cosmos that can build stars and chemistry and minds. Now ask the winner why they won. Of course they won. A loser could never have asked the question. So finding yourself holding a winning ticket tells you nothing about whether the lottery was rigged or whether there were simply so many tickets that some winner was bound to appear. Both stories explain the ticket in your hand equally well. That is exactly our situation. The fine balance might be rigged, or it might be one lucky draw among countless unseen ones. From inside a winning ticket, you cannot tell the two apart. Not yet. That is either a complete answer or no answer at all, depending on your temperament. And I love that we cannot yet tell which, because here is what all three threads truly converge on. Not a proof of design, not a proof of luck, but something quieter and far more honest. Every one of these near impossibilities marks a place where our rulebook is incomplete. Every one is a signpost saying there is more physics here that we do not yet understand. The imbalance of matter points to some process still not fully pinned down that tipped the scales in the first instant. The fine balance of expansion points to some mechanism still being tested that drove the universe onto its knife edge. The abundance of carbon pointed to a hidden resonance that had to be predicted before it was found. Do you see the pattern? Every impossibility is a door. Your existence is not a violation of the laws of physics. It is a clue that the laws of physics, as we have written them so far, are unfinished. You are not proof of a miracle. You are proof of a mystery. And a mystery is a far better gift, because a miracle ends the conversation and a mystery begins it. A miracle says, stop. There is nothing more to understand here. A mystery says, look closer. There is more waiting for you than you imagined. And every one of these three doors is a mystery, not a miracle, which means every one of them is an invitation. That is the convergence. 3 roads, 3 impossibilities, 1 destination. The universe did not break its laws to make you. It revealed that we have not yet finished reading them. So let's bring it home. We started with a strange claim that the atoms in your 2 hands came from different stars, and that by the plainest reading of the rules, you should not exist at all. And I asked you to sit with the discomfort of not immediately knowing how anyone could possibly claim to know such a thing. So we built the tools first. We established that looking far into space is the same as looking back through time, because light has a speed limit and carries the past to us intact. We measured the depths of that past with redshift, the stretching of light as the universe expands. We walked up to the oldest light there is, the cosmic microwave background, and we accepted it as a genuine wall, an edge to what looking can ever reveal. And we agreed on the one rule that separates real knowledge from empty story. A claim is only worth believing if it could have been proven wrong. It has to be falsifiable. And when 2 explanations both fit, we take the simpler one until the evidence forces us onward. That was the ground we stood on for everything that followed. Then we walked through the first impossibility, matter and antimatter, twins that annihilate on contact, and the plain prediction that the early universe should have made them in perfect balance and canceled itself into an empty glow. But it did not. It kept a surplus, 1 part in a billion. And we could even count the leftover light to measure how tiny that surplus was. You are built from those survivors, from a rounding error, 1 part in a billion deep. A billion pairs annihilate, 1 lone dancer is left standing. And every star you have ever seen is made of those lone survivors. We walk through the tug of war between the outward rush of expansion and the inward pull of gravity, and the razor-thin balance required for the universe to neither crush itself nor scatter into cold fog, a precision finer than hitting an atom with a dart thrown across the whole cosmos. A pencil balanced on its point for 14 billion years. And the universe landed on that edge at the very first instant, with no second try, at the exact moment when any error would have grown the fastest. And we walked through the 3rd carbon, the backbone of you, which should have been nearly impossible to forge because the ladder to build it has a broken rung, a 2-helium object that falls apart in a flicker. Yet carbon is everywhere because there is a hidden resonance, a matched frequency, a push on the swing at exactly the right beat that lets the bridge get built. And the astonishing thing is that this resonance was predicted from nothing, but the fact that carbon-based creatures existed to do the predicting. Your existence was the evidence, you were the test, and the universe passed. 3 impossibilities. Same shape every time. The rules predict a dead cosmos, the cosmos is alive, and you are the proof. And when we laid all 3 side by side, they pointed not at a miracle and not at mere luck, but at something better. They pointed at the unfinished edges of our own understanding. Every impossibility a door, every improbability a place where there is more to learn. That is the whole journey from an impossible question to a far richer one. Now, let me be scrupulously honest with you about what remains open, because a guide who hides the gaps is no guide at all. We do not know why there was more matter than antimatter. We know it happened because we are here and we can count the leftover light. But the exact process that tipped the balance in that first instant has not been fully identified. It is an active question with real candidate answers, none yet confirmed. We do not know why the balance of expansion and gravity sits precisely where it does. There are good ideas, some tested against the ancient ripples with real success, but the deepest why is not settled. And we cannot say whether the apparent fine-tuning of the universe means anything at all, or whether it is simply the unremarkable fact that only a balanced universe could ever have someone in it to notice. And there are larger silences still. We do not even know what most of the universe is made of. There is a great deal of unseen mass out there, something we call dark matter, whose gravity we can feel tugging on galaxies, but whose nature we have not identified. We know it is there because of how it bends light and holds galaxies together, and we can even map it using gravitational lensing, watching how it warps the light from more distant objects. But what it actually is remains one of the great open questions. So even the ledger of what exists is incomplete. We are reasoning about the origin of everything while still not knowing the full contents of the room we are standing in. And that is not a scandal. It is simply where the frontier sits today. We do not know if we are alone. We have frameworks for thinking about it, like the Drake equation, a way of breaking the huge question of cosmic company into smaller pieces we can chip at one at a time. How many stars? How many with planets? How many of those in the right place? How many where life begins? How many where it lasts? We do not know most of those numbers yet, but the equation tells us exactly which numbers we would need. We have the Fermi paradox, the nagging puzzle that if life should be common, we ought to see some trace of it, and so far we see silence. Every year we find more exoplanets, more worlds around other stars, and more of them sitting in the Goldilocks zone, the comfortable band where a world is neither too hot nor too cold, and liquid water could pool on the surface. We watch the strange interstellar objects that pass through our neighborhood, visitors from other systems, drifting in from beyond the Kuiper Belt at the cold outer edge of our own. We study their odd non-gravitational acceleration, the small extra push that is not fully explained by gravity alone, and we ask honest questions about what they are, almost certainly natural. But we look and we ask because that is the discipline. But a true biosignature, a fingerprint of life on another world, has not been confirmed, nor has a technosignature, a sign of someone else's technology. These are not embarrassments to be hidden. They are the honest boundary of what is known, and I can tell you almost exactly where that boundary sits. That precision about our own ignorance is the most trustworthy thing we have. And that, in the end, is what scientific literacy really means. Not a head stuffed with facts. It means knowing how we know and knowing exactly where the knowing runs out. It means applying Occam's razor, preferring the simpler explanation until the evidence forces a more complicated one, and it means holding every belief lightly enough to drop it the day a better observation arrives. That habit of mind is the whole inheritance. It is available to anyone in any chair, and it is the thing that lets an ordinary person walk right up to the beginning of the universe and reason about it without flinching. You have been doing exactly that for the last little while, and you did not need a single equation to do it. So here is what I hope you carry out of this. Not a fact to memorize, but a way of holding the world. Your existence really is, by the plainest reading of the rules, something close to impossible. The atoms in your two hands really did come from different dying stars. Matter really should have annihilated itself, the universe really should have crushed or scattered, and carbon really should have been too hard to make. And you are here anyway, made of survivors, held together on a knife edge, built from a bridge that almost was not there. But the point is not to feel small, and it is not to feel chosen. The point is to feel awake, because every one of those impossibilities is a place where the universe is still keeping a secret, and you have the extraordinary luck to be alive at a moment when we can actually walk up to those secrets and reason about them from an ordinary chair. No credentials, no priesthood, just careful thinking, one honest step at a time, and the willingness to say clearly where the knowing stops. That is the cosmic perspective, and it does not diminish you. It does the opposite. You are the universe's rounding error, its knife edge, its improbable bridge, and also somehow the part of it that gets to understand all three. The cosmos spent nearly 14 billion years through annihilation and balance and the forging of carbon in the hearts of stars, arranging itself into something that could look back and ask why. And here you are, doing exactly that. A little patch of ancient stardust, reassembled just so, wondering about its own beginning. If that does not stir something in you, I am not sure what could. If you have felt even a flicker of that wonder while we talked, then I would be genuinely glad if you subscribed and stayed a while so we can keep walking up to these beautiful open questions together. There is no rush and there is nothing to buy. Just more of this whenever you would like it. Thank you truly for giving me your time and your attention. It is the one thing none of us can make more of, and you spent some of it here thinking about the impossible fact of your own existence. I do not take that lightly. Until the next one, keep looking up and keep asking why.